Hi viewers, this is Dr. Jana, and in this video we will be discussing about the multiple linear regression. Right, in our previous video we have gone for this simple linear regression. We will be going for this multiple linear regression. What is the meaning of this? Previously, against one independent variable we are going to predict one dependent variable. For example, say the sell according to the advertisement or like that. So we have seen, but here imagine we are taking a data set like our power plant data. Here we are having the ambient temperature, some atmospheric temperature, the vacuum, the pressure, the humidity, and also power transmission. That all these things are there. So this is our database, and we are having around you can see the size. It is around some 500 plus data are there available, right? So for this, what we need to do, I want to predict the P based on the remaining 5 AT, V, AP and RH. I told you that RH stand for this humidity, P stand for the pressure, V for the vacuum and T for the temperature, right? So these are the, and temperature is given in centigrade, degree centigrade, all things, right? So now the data is available. So this data you can download and you can keep it there. If it is not in the CSV file, then we can convert into the CSV file, because it will accept only the CSV file, because the method we are using pd.read_csv. Then this whatever the file, that is the powerplant.csv I converted, that is there available in a folder, that is ML tutorials in my D drive. So for that what we do, so this path we put it complete path. So by default it will come D, backward slash will come, only the slash forward slash you convert, right? So up to this it is there, and whatever the data you read, that you keep it with a variable data1. So now it is dealing as data1. So now whatever things I have to see, I have to use the data1. Suppose I want to see the first 10 lines of this data. So data1 dot head. What is the data1? Data1 is the what I got it here. What the database I read it here, that I store it as the data1. So data1 dot head 10. If data1 dot head, by default it will take only 5 lines, because I have given 10 number of lines, 0 to 9 is there. Then what next we need to do? We define x and y. So what will be x and what will be y? Then what is x? Can you tell me somebody? Because what will be there, the independent variable. Here out of 1, 2, 3, 4, 5 columns, the first 4 will be the independent variable, and the last one we are going to predict. Then how do you represent that x-axis? You see, in that case I have to drop the last item. Okay, so how do you drop? So you write data1 dot drop. Which one I want to drop? Data1. From the data1 you drop PE. This PE I want to drop. So got it now? Data1 dot drop PE, comma axis is equal to 1 dot values. All these values you drop and store it in x. That means x axis represent all these value like AT, V, AP, RH. That means you got it now. So that way I call the multilinear. It is not a x versus y, x1, x2, x3, x4 versus y. Clear? So this is the things. So based on these things only it is going to predict the P. Fine. Then this is your x-axis represented like this. Then how to represent y? Y is equal to data1 of what? That's P. P what we drop, that we put it in the, because we are going to predict y, right? So then print x, then you can see these are the data, and print y also you can see all this data. Now what I need to do? I need to split the data into training and the test sets, right? How to do? So I told you that scikit-learn. So sklearn, from sklearn dot model underscore selection, then import train underscore test underscore split. So these are things you are going to import, right? So you imported. Why I am importing all the things? It is just dividing the data into training and test. Then we define x underscore train, x underscore test, y underscore train and y underscore test, which is equal to, from this method train test split, what are the things are there? X, y and test size is equal to 0.3. I am giving the test size is equal to, that means 30% data is test and 70% data is for training. That's why I am writing test size 0.3 and a random state I am putting it 0, right? Then what we need to do? Then I have to train the model. How do you train the model? For training the model, again we need the sklearn, scikit-learn. So from sklearn dot linear underscore model, import linear regression. First to import the linear regression, that linear regression method store it as LR. Okay, Then to feed these things, lr dot feed x underscore train comma y underscore feed. So when you run this thing, it is showing yes, the linear regression, it is there, it is done. Then I need to go for the predictions. How to predict? See, y predict, which is equal to lr dot predict. Are you following me? That means against the x. What is the x test? You understand? X test, x underscore test means whatever the data I have given, 30% of the data from 80 to
Sir. Sir, come to conference hall, sir. Surabh sir.
So now what you have done, we did these things. Then what exactly we do? We need to fit for that fitting of this data. What is the meaning of this fitting? So we have to put it just like a y is equal to mx plus c, like that, in that form. So lr dot fit x underscore train y underscore train. So these are the things we do, and it is done. Then for calculate this y predict which is equal to lr dot predict x underscore test, then print y test. So when we are printing y test, that means against the x test, that is 30% of that data, that is x1 x2 x3, for that I am predicting the y underscore predict. So the data I find this, up to this I find it there, but this is already existing, okay, but I want to predict for a particular data. So out of the data, so suppose I go for this one, for this x1 x2 x3 x4, and I will change randomly this value also, 1014 I will change it. So this data I copy and paste it here. So lr dot predict for this one, that 1014, instead I change it to 1015.2. Then when I am giving, so the output, it is coming 463.4. You remember that 463 point something, okay, but actually what are the, this is the last three, last but 3. So last but 3, it was 465 actually, because I modified some data. Instead of 465, it is coming 463. You got it now? So it has predicted now. Now you need to evaluate the model. For evaluate the model, again you go to the sklearn dot matrix. Here import R2 score. How do you go for this R2 score? Y test and y predict. Between this I want predict. So when I am putting this R2 score, it is coming 0.92 something. This is coming, that you remember this thing. Then I want to plot the results. For plotting the results, I want to import the matplotlib. So import matplotlib dot pyplot as plt. Then I need to scatter plt dot scatter y test versus y predict. So y test for the testing data and the plotting the predicted value, all the things I am putting. But you see, it is not in a line. There is some difference there. Okay. So then what you need to do? Then plot. Suppose I put the x label is actual and y label I put it predicted, and actual versus predicted, the cumulative data you can see it here, it will come here. Okay. So this is the actual and this is the predicted, this is the actual, because you put at a time it will show. Now what you need to do, the predict y underscore df. So suppose I want to predict the values. So predict y equal to df dot data frame, actual values is equal to I put it y test, and the predicted values I put it y predict, and difference is equal to y test minus y predict. Okay. Then if I go for this predict y under df, because the difference what I put it here, that I put it as in this predict underscore y dot underscore df. So if I take 0 to 20, so 20 number of data, if I want to put it here, you see this is the actual value, this is the predicted value, and this is the difference. You see our difference, maximum difference is 7 point something, it is there. Okay. Even if 0, 6 like that, it is coming. So it indicates that the difference is very less. So we can accept this model, and this model is ready, so it can be used for any prediction. Fine. So this is all about the multiple linear regression, and the only difference is there in the linear regression, simple linear regression, we are putting x versus y. But here multiple x are there, x1, x2, x3, x4, x5, any number x you can take it here, and value is equal to y. Then initially what we did, what is to be predicted first to drop. So without that you put it in the x underscore data or x axis, and what you want to predict, that you put it in the y axis. Then you can print x, print y, all the things you do. Then we need to split the data train test, so that we did it using these things, and here random state is equal to 0 and test size is equal to 0.3. Then what we did, we to fit it, we have gone for this LR, that is the linear regression, that is from sklearn, this model. Then we put it using this, fit it in this command lr.fit. So then we have done, and finally we got this model. Okay, thank you for watching this video. If you like this video, please do share with your friends, and also don't forget to subscribe. Thank you for watching this video. Please take care of your health. Bye bye.